Hi all, welcome to GATE Matra Class 2 on Periodicity of Signals. In today's class, we will see how to compute fundamental period of a given signal, which is a very common question in many GATE and public exams. To find the periodicity of a continuous time signals, we are looking at three types of periodicity problems. The first one is where you have integers, the second problems where you have fractions, and the third type of problem where you have both integers and fractions. In today's class, we will see what is the best strategic method to solve these problems in GATE exam. Periodicity of integer problem 1. Cos 6 pi t plus sine 10 pi t. The first step in any such problem is to find or to check how many 2 pi's are contained. In this question of cos 6 pi t plus sine 10 pi t, you have 3 2 pi's with cos and 5 2 pi's which is 10 pi t. Now, we need to find the periodicity of just 3 and 5, not 6 and 10. So that is the first step in computing the periodicity of integers. Now, for the numerators or the periodic integers 3 and 5, what is the common or the combined fundamental period? So in order to find the fundamental period of mixed signals, we use multiple scales for 3 and 5. In this case, we write the multiples of 3 on one scale and the multiples of 5 on the second scale. And then we look for the common term on the both scales. In this case, which is value 15. Hence, your combined fundamental period for this mixed signal is 15, which is your answer choice D. Here we have other similar questions for periodicity of integers. Now let's look at few more examples for integer periodicity before we go into much difficult fractional periodicity. In this example, we have 4 pi and 6 pi, which contains 2 and 3 2 pi's. The first step is to do that, and then we write the multiple scale for 2 and 3. And then what do we see is sometimes you encounter two common terms. This is because you don't stop writing at 6, you keep on going till 12, and you write the same for the multiple scale for 3. And then eventually you get confused which one to choose as your combined fundamental period for your mixed signal. In this case, the answer is always the smallest common term, which is 6 in our question. The answer cannot be 12, and if you choose 12, you will be ending up with the wrong answer. Good. Next question is 12 pi and 14 pi. So when you take 12 pi t and 14 pi t, it contains the first step 6 2 pi's and 7 2 pi's. Now writing the multiple for 6 and 7, you end up getting the common term at 42, which is after 6 to 7 terms on the multiple axis. This is another question where you don't end up getting a common term till you reach a certain number of values. For 8 and 9, you will get it at 72. So the point is you keep writing these values on the multiple scale unless and until you reach a common value, which is going to be the combined fundamental period. You need to extend these values on the multiple scale. In this case, the answer is 42. Now, a 3 mixed signal question. This is the most common question which we have seen in GATE, but the integer periodicity is very, very rare. They are asking both integer and fractional periodicity problems in the GATE exam. But let us look at this question, how to solve this question. So a 3 mixed signal problem is exactly the same way as your 2 mixed problem. So there are certain places where you need to be careful with this 3 mixed signal. So we have 2, 4 and 3 2 pies. So we write the multiple scales for 2, 3 and 4. What do we have here? As you can see, 4, 6, 8 and 12. So if you have to pick a common term for this 3 mixed signal, you can end up picking these 4. But look more carefully. 4 is common only on the 2 scale and 4 scale. 6 is common only on 2 and 3 scale. 8 is common on 2 and 4 scale. And 12 is common on all 3 scales. So the answer in this case would be 3. 12. Not the first 3, but 12. So 12 is common to all 3 numbers 2, 3 and 4. Now let's take a look at periodicity of fractions, which is the next category. So in this case, the first step is the same. Where you find how many 2 pies are contained. So here we are looking at 3 by 2 and 5 by 6 2 pi. So we are looking at fraction of 3 by 2 and 5 by 6, for which we need to find the combined period. So how do we do that? The first step is to separate these fractions into numerator and denominator. The numerator of 3 by 2 and 5 by 6 is 3, 5, and the denominator is 1 by 2 and 1 by 6. And now what we are going to do is we are going to treat numerator separate and denominator separate. The numerator we are going to find the same way as integer periodicity. So for 3 and 5 we are going to use the multiple scales 3 and 5. The common term is 15. So the numerator period is 15. So that is done. Now let's come to the denominator. So let's see what is happening at the denominator fraction, which is 1 by 2 and 1 by 6. This is new here since we are dealing with the periodicity of fractions. So for this 1 by 2 and 1 by 6, what we are going to do is we are going to write some fraction. So it's very simple. It is just like you write 1 by 2 and 1 by 6 scale, which sums to 1. So you write 1 by 6. Then you have 1 by 6 plus 1 by 6, which is 2 by 6. Then 2 by 6 plus 1 by 6, 3 by 6. So you keep adding 1 by 6 to each of these scales. So 1 by 6, 2 by 6, 3 by 6, 4 by 6, till you come to 1. For 1 by 2, you just have to write it twice, then you get to 1. 1 by 2 plus 1 by 2 is 1. This is the scale that we are using for the denominator fraction. And then what do we do is we need to see for the same value on the two axes. So 3 by 6 and 1 by 2, 6 by 6 and 1. So you have 3 by 6 is 1 by 2, which is equal to 1 by 2. So in this case, the two positions which are matching, so which means the fractional period is given by 1 divided by the number of matching positions. Here the number of matching position is 2, so the fractional periodicity of a mixed signal is 1 by 2. So what is the combined fundamental period? So the combined fundamental period is going to be 15 for the numerator, 1 by 2 for the denominator. The fractional fundamental period is 15 into 1 by 2, which is 15 by 2. Good. So let's do one more question with 3 signals and fractions. So we are going to see a 3 fractional periodicity problem which is given here. So let's see how many 2 pi's are contained here. So you can see we have 3 by 2, 2 by 6 and 5 by 4. So we have 3 fractions here, 3 by 2, 2 by 6 and 5 by 4. So numerator is 3, 2, 5 and denominator is 1 by 2, 1 by 6 and 1 by 4. So 3 to 5 we write on a multiple scale and we get the matching periodicity on all three axes at value 30. So we have 6 common on 2 and 3, 10 and 3, 10 on 2 and 5, 12 on 2 and 3, 18 on 2 and 3, 20 on 2 and 5, 24 on 2 and 3, 30 on 2, 3 and 5. So the common value is 30, which is on all three multiple axes. Hence the fundamental period of your numerator is 30. Same as what we have seen till now. Let's come to the fraction. The fraction goes the same way. We write the three fractions in this manner. 1 by 6 goes 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 1 by 2 and 2 by 2. And look at how many common terms are there on all three. So we have, or in this case it's not common, it's more like matching terms, and we have at two places. 3 by 6 is equal to 1 by 2, 2 by 4 is equal to 1 by 2, and 1 by 2 equal to 1 by 2. 6 by 6 is equal to 1, 4 by 4 is equal to 1, and 2 by 2 is equal to 1. And we need to do this till 1. So that is one of the thing. You have to increment them to unity. So if you see, increment them to unity. So that is where we do. And now the number of matching terms is 2. Again, the periodicity of the denominator is 1 by 2. In this case, we have period is 30 and period is 1 by 2. Fundamental period of the overall signal is 30 into 2, 1 by 2, which is 15. Good. So that is how you find the integer periodicity and fractional periodicity. This is a new method that I have been teaching my students. So I hope this method helps you in solving any periodicity question on GATE, and the discrete part of this will be shared on the next class. Thank you for listening. I hope this class was helpful to you.